Hello students, welcome to our channel Learning Notebook. In today's video, we will do complete chapter of Symmetry and Patterns for class 5. Before starting with this video, let me tell you that we have made videos on every chapter of class 5 mathematics. We also have interesting worksheets and quizzes on each chapter. You can find all of them on our channel Learning Notebook. Also, you can see a list of all such videos on our website. The link to our website is below in the description box. So let's see what all topics we are going to cover today in this video. First, we will understand what is symmetry and line of symmetry. Then we will learn symmetrical figure and asymmetrical figure. Then symmetry in plane figures, symmetry in alphabets. After that, we will learn mirror image and reflection symmetry number. Then rotational symmetry, nets and tessellations. After that, we will do different tessellations, patterns, pattern of square numbers, sum of consecutive odd numbers to get square numbers, how to find difference of square numbers, triangular pattern, and then students, in the end, I will give you a worksheet for your practice. So let's start and first learn what is symmetry and line of symmetry. A figure is said to be in symmetry if it can be folded or divided into two equal halves of same shape and size. Students, let's understand this with the help of an activity. Take a rectangular paper and fold it into two halves as shown here. Now open this page and you will notice that both the halves are of equal shape and size. This is called symmetry. A figure is said to be in symmetry if it can be folded or divided into two equal halves of same shape and size. Now, what is line of symmetry? A line which divides the figure into two equal parts is called line of symmetry. Here in this rectangular paper, this line which is dividing the figure into two equal parts is the line of symmetry. Now students, I am sure you have understood meaning of symmetry and line of symmetry. Now our next topic is symmetrical figure and asymmetrical figure. Figure which can be divided into two equal halves is called symmetrical figure. That is, figure having symmetry is called symmetrical figure. For example, rectangle. Rectangle is a symmetrical figure because it can be divided into two equal halves. In the same way, oval is also a symmetrical figure because it can also be divided into two equal halves. Similarly, a plus symbol is also a symmetrical figure. As you can see, it can also be divided into two equal halves. And students, all these dotted lines, these three dotted lines are line of symmetry because they are dividing the figures into two equal halves. And now what is asymmetrical figure? Figure which cannot be divided into two equal halves is called asymmetrical figure. For example, this figure. It cannot be divided into two equal halves, right? Then this figure also. It also cannot be divided into two equal halves. And same for this figure. So all these three figures are asymmetrical figure. Here students, we have no line of symmetry as well. So we can also say that figure having no line of symmetry is called asymmetrical figure. Now students, let's do some questions. State if the following figure is symmetrical or asymmetrical. Look at this first figure. If we fold this figure vertically or horizontally, it cannot be divided into two equal halves, right? So this figure has no line of symmetry. Therefore, this figure is asymmetrical figure. Now see this heart figure. If we fold this heart figure vertically, then we will get two equal halves. So this heart figure is having a line of symmetry. Therefore, it is a symmetrical figure. Then this smiley figure. The smiley figure can also be folded into two equal halves as shown here. So this is also a symmetrical figure. Next question is, draw the line of symmetry for following figures. Look at this first figure. Here we have to draw line of symmetry. It means we have to draw a line which will divide this figure into two equal halves. So how will we draw this line? We will draw line of symmetry like this. Vertical line of symmetry. This line will divide this figure into two equal halves. Now look at this second figure. Here also students, we will draw a vertical line of symmetry which will divide this figure into two equal halves. Now take a look at this third figure. Can you tell me how will we draw line of symmetry in this figure? Yes, here also we will draw a vertical line of symmetry. But this figure can also be divided into two equal halves by drawing a horizontal line of symmetry. So this figure has two lines of symmetry. So now students, I am sure you have understood symmetrical figures, asymmetrical figures and how to draw line of symmetry. Let's move to next topic, symmetry in plane figures. Here students, we will learn symmetry in triangle, symmetry in rectangle, in square and in circle. Students, first let's learn about symmetry in triangles. Triangles are of three types: isosceles triangle, equilateral triangle and scalene triangle. First let's learn about isosceles triangle, symmetry in isosceles triangle. So what is isosceles triangle? An isosceles triangle is a triangle where two sides are equal. So, isosceles triangle has one line of symmetry as shown here. So, this is the symmetry in isosceles triangle. It has one line of symmetry. Now, let's learn symmetry in equilateral triangle. An equilateral triangle is a triangle whose all the three sides are equal. All these three sides, they are equal in equilateral triangle. An equilateral triangle has three lines of symmetry as shown here. So these are the 3 lines of symmetry in an equilateral triangle. Let's see symmetry in scalene triangle. Scalene triangle is a triangle which has no equal sides. All the 3 sides are of different length. A scalene triangle has no line of symmetry. So this was about symmetry in 3 types of triangles. Now let's learn symmetry in next plane figure, which is rectangle. A rectangle has 2 lines of symmetry. One is vertical and other is horizontal. So these are 2 lines of symmetry in a rectangle. Next is symmetry in square. A square has 4 lines of symmetry: vertical, horizontal and diagonals. So these are 4 lines of symmetry in a square. Now let's see symmetry in last type of plane figure, which is circle. Students, a circle has many lines of symmetry. See here. Vertical, horizontal, diagonal. You can have many lines of symmetry in a circle. Now let's see symmetry in alphabets. Students, there are some alphabets which have one line of symmetry. In one line of symmetry, we have alphabets with horizontal line of symmetry and we have alphabets with vertical line of symmetry. Then there are some alphabets with 2 lines of symmetry, while there are other alphabets which have no line of symmetry. So let's learn in detail about symmetry in alphabets. First, let's see alphabets with horizontal line of symmetry. B. B has horizontal line of symmetry as shown here. C. Next alphabet is D. Then E. After that, we have K. So all these alphabets B, C, D, E, K, they have horizontal line of symmetry. Students, can you tell me any other alphabet which has horizontal line of symmetry? Do let me know below in the comment section. Now look at the alphabets which have vertical line of symmetry. A. A has vertical line of symmetry. M. Next alphabet is T. Then we have U. W. All these alphabets have vertical line of symmetry. A, M, T, U, W. Right, students? Do you know any other alphabet which has vertical line of symmetry? Comment right now. Now let's see alphabets which have 2 lines of symmetry. H. H has 2 lines of symmetry, vertical as well as horizontal. Similarly, I, O, X. All these alphabets have 2 lines of symmetry, vertical as well as horizontal. Now, which are the alphabets which have no line of symmetry? Let's see. F. Students, F has no line of symmetry because either we draw horizontal or vertical line. We cannot divide F in two equal halves. Same for alphabet G, J, L. All these alphabets have no line of symmetry. F, G, J, L. Next, we are going to do a very important topic, mirror image and reflection symmetry. When we look at the mirror, we see our image. This is known as mirror image. Like here, when this boy is looking at the mirror, he is seeing his image. This is known as mirror image. Students, do you know why this image is formed? This image is formed in the mirror due to reflection. For example, cut out a triangle from a paper and put it in front of a mirror as shown here. You will see another triangle formed in the mirror. Like here, you can see another triangle is formed in the mirror. This triangle is the mirror image or reflection. And this line, which divides the figure into two equal halves, is called line of symmetry. Now you must have understood what is mirror image. Next, let's learn what is reflection symmetry. Reflection symmetry is a type of symmetry about reflections or mirror images. It is also known as line symmetry or mirror symmetry. Students, a figure has to have at least one line of symmetry to be considered as a figure with reflection symmetry. Let's understand reflection symmetry with the help of few examples. Students, does butterfly exhibit reflection symmetry? Answer is yes, because the wings of butterflies are identical on both the sides and therefore butterfly exhibits reflection symmetry. Let's see one more example. Our faces. Students, our faces are identical on left and right side and thus our face exhibits reflection symmetry. Now students, if we are given one half of a figure and its line of symmetry, then we can easily complete this figure using concept of reflection symmetry. Let's see how. Students, look at this picture. Here we are given a half heart and a line of symmetry. Now, if we place a mirror on its line of symmetry, it completes the heart figure as you can see here. Therefore, we can use concept of reflection symmetry to complete the figure. Let's see one more example. Here, take a look at this picture. We are given half x and a line of symmetry. So again, if we place a mirror on its line of symmetry, it completes this picture. Right, students? So, now I am sure you have understood the concept of reflection symmetry and how to use this concept to complete a given figure. Now next let's understand rotational symmetry. Students, to understand rotational symmetry, first we need to learn what is rotation. Rotation means a circular movement around center. For example, take a look at this picture. If we move it around the center, it will move like this. So this circular movement is called rotation. A shape has rotational symmetry when it still looks the same as original after some rotation. And rotation can be clockwise, anti-clockwise, or rotated with any angle such as 90 degrees, 180 degrees, etc. Let's see some examples. In first example, this arrow has rotational symmetry. Let's see how. Students, take a look here. This is the original position of this arrow. Now this arrow will have rotational symmetry if it returns to its original position after rotation of an angle. Like if we rotate this arrow, it returns to its original position after the rotation of 360 degrees. So this shows that this arrow has rotational symmetry. Second example is square. Square has rotational symmetry at 90 degrees, 180 degrees, 270 degrees and 360 degrees. Let's see how. This is the original position of a square. If we rotate this square, let's say by 90 degrees, it returns to its original position. Right? Now again, if we rotate this square by another 90 degrees, in total, after the rotation of 180 degrees, then students, again, it returns to its original position. Now, again, rotate this square by 90 degrees. That is in total by 270 degrees. You will see the square has returned to its original position again. And in the end, at the rotation of 360 degrees also, the square returns to its original position. So this means a square has rotational symmetry at 90 degrees, 180 degrees, 270 degrees and 360 degrees. Now our last example of rotational symmetry is letter H. It says letter H has rotational symmetry at 180 degrees and 360 degrees. Let's see how. First students, let's rotate this letter H by 90 degrees. See, H has not returned to its original position. So, letter H has no rotational symmetry at 90 degrees. Now, let's rotate it by 90 degrees more. That is at 180 degrees in total. Now, it has come back to its original position, right? Next, rotate this letter H by 360 degrees in total. And you will find it has come back to its original position again. So, this shows that letter H has rotational symmetry at 180 degrees and 360 degrees. So, students, this was about rotational symmetry. Now, let's move to our next topic, quarter turn and half turn. Quarter turn, or we can also call it as 1/4 turn. Quarter turn means rotating the shape by 90 degrees. Now look at this figure. Here, let's give a quarter turn to this figure. It means we have to rotate it by 90 degrees. Right, students? In the same way, let's give a quarter turn to this second figure. It means we will rotate it by 90 degrees. Next is half turn, or we can call it as 1/2 turn. Half turn means rotating the shape by 180 degrees. Like here. Let's give a half turn to this shape. This means we will rotate this figure by 180 degrees. Similarly, let's give a half turn to this figure. Again, we will rotate this figure by 180 degrees. So this is the shape of this figure now after half turn. So students, you can get questions in your exam like you will be given a figure and you will be asked to draw that figure after quarter or half turn. Let's do a question. Tell if the following figures will look the same after a quarter turn or a half turn. So here students, we are given with these three figures and we have to tell whether they will look the same. That is, will they be in their original position after the quarter turn or after the half turn. So look at this first figure. It is a circle. So yes, it will look the same after a quarter turn as well as after a half turn. Right, students? Now, this is the second figure. Let's give it a quarter turn. See, after the quarter turn, this figure is not the same as the original one. Now, let's give it a half turn. Yes, now it looks same as the original one. So, it means this figure will look the same after the half turn. Now, look at this third figure. So, first let's give it a quarter turn. See, this figure is not the same as the original one. So, now let's give it a half turn. Yes, now it looks the same as the original one. So, this figure will also look the same after a half turn. Now, our next topic is nets. A net is a two-dimensional shape that can be folded to form a three-dimensional shape. Let's understand this with the help of an example. Take a sheet of paper and draw 6 squares of side equals to 6 cm as shown here. Then cut it along the sides. Now students, fold this cutout in the form of a cube as shown here. So here we have folded a two-dimensional shape into a cube, which is a three-dimensional shape. So arrangement of 6 squares is the net of a cube. Similarly, rectangle is the net of an open cylinder. And rectangle along with two circles is the net of a closed cylinder. So this was about nets. Let's move to our next topic, tessellations. So what is tessellation? The design that fits into each other without any gap or overlapping is called tessellation. For example, look at this design. It fits into each other and there is no gap or overlapping. So this is tessellation. Tessellation follows a pattern, and pattern can be created using curved and straight lines. Like look at this first figure. It's a tessellation and it is following a pattern which is created using curved lines. These are the curved lines here, right? Now look at this second figure. This is also a tessellation and here pattern is created using straight lines. These are the straight lines here. Now let's understand the rules for tessellation. Rule 1 is tessellation must tile a surface without a gap or overlap. This is the first rule, students, that in tessellation there should not be any gap or overlapping, right? Now rule number 2 is tiles must be of same size. Like here in this tessellation, all the tiles, they are of same size. You can look at any tile. All of them are of same size. Now third rule is each vertex must look the same. Here students, this is a vertex and every vertex, be it this vertex or this, every vertex looks same. You can check any vertex, it will look the same. So these are the 3 rules for tessellation. Now students, look at this pattern. Can you tell me if it is a tessellation or not? Yes, here these circle tiles, they are of same size. And each vertex is also looking same, right? So tell me whether this is tessellation or not? No, this is not a tessellation because there are gaps between these tiles, these gaps. And as per rule number 1 of tessellation, there should not be any gap or overlap between tiles. So this pattern is not a tessellation. Now let's talk about different tessellations. Rectangular tessellation. So what is rectangular tessellation? The arrangement of bricks on a wall is an example of rectangular tessellation. Next is triangular tessellation. Triangular tessellation is where triangles are arranged in a pattern. As you can see here, this is a triangular tessellation. And last is square tessellation. Square tessellation is where squares are arranged in a pattern. Like here, squares are arranged in a pattern. So this is a square tessellation. So this was all about tessellation. Next, let's move to our very important topic, patterns. A pattern is a sequence of repeated numbers or shapes or objects. For example, here is a pattern 2, 4, 6, 8. We have to fill these blanks by identifying this pattern. So here numbers are 2, 4, 6, 8. So students, we can see that these are multiples of 2. Therefore, next number in this pattern will be 10, then 12, and lastly we will write 14. So this is a pattern here. It is a multiple of 2. 2, 4, 6, 8, 10, 12, 14. Let's see some more examples. Here numbers given are 11, 22, 33, 44. So first let's identify this pattern and then only we can fill the blanks. So here we can see that these numbers are multiples of 11. So next number will be 55, then 66 and last 77. Now look at the second pattern. 1, 4, 7, 10. Let's first identify this pattern. So here students, if you observe carefully, you will find that we are getting the next number by adding 3 to the previous number. Like 1 plus 3 equals to 4. Then 4 plus 3 equals to 7. 7 plus 3 equals to 10. So next number will be 10 plus 3 equals to 13. Similarly, 13 plus 3 equals to 16 and 16 plus 3 equals to 19. So in this way, we have completed this pattern. Now let's see the last pattern. 2, 4, 2, 4. So here there is no addition or multiplication, but it is following a repeated pattern. See, 2, 4, 2, 4. So numbers are being repeated. So next numbers will be 2, 4 and 2, 4. Right students? So students, to complete a pattern, first we have to carefully identify the given pattern and then only we can fill the blanks. Students, pattern can also be created by repeating the shapes. For example, see here. This is a pattern created by repeating the shapes. First, there is one pentagon, then one circle, then again one pentagon and then again a circle. So here, pattern is created by repeating a pentagon and a circle. Right? Now look at this second pattern. There are two stars and one diamond shape. Then again two stars and one diamond. So here pattern is created by repeating two stars and one diamond. Next, pattern can be created by rotating shapes by quarter turn or half turn. For example, let's create a pattern using quarter turn. Quarter turn means by rotating the shape by 90 degrees. See this shape. This is an arrow. Let's move this arrow by quarter turn. Means let's move this by 90 degrees. So arrow will look like this. Now if we repeat these two shapes, then we can create a pattern using quarter turn as shown here. Right students? Similarly, now let's create a pattern using half turn. This is an arrow. This time, let's move this arrow by half turn. That is by 180 degrees. So arrow will look like this. Now, if we repeat these two shapes, Then we can create a pattern using half turn, as you can see here. So these are the patterns which we have created by rotating shapes by quarter turn or half turn. Now let's do a question. Complete the following pattern. So here we are given this pattern and we have to complete it. So first we have to identify this pattern and then only we can complete it. So let's identify this pattern first. Look at this pattern, students. Orange rectangle is only 1 in all these 3 figures. It is same in all these 3 figures. But this blue rectangle is increasing by 1 in each figure. See, in first figure, blue rectangle is 1. In second figure, blue rectangles are 2. And then in third figure, there are 3 blue rectangles, while there is only 1 orange rectangle in all these 3 figures. So, what should be the next figure in this pattern? In the next figure, we should have 1 orange rectangle and how many blue rectangles? Yes, 4. 4 blue rectangles. So, this is the way we have completed this pattern. Now, look at this second pattern. First, let's identify this pattern. Here, in the first figure, we have only 1 ball. Then, in second figure, there are 3 balls. And then, in this third figure, there are 5 balls arranged in the shape of alphabet L. So, here students, number of balls is increasing by 2 in each figure. So, in the next figure, in the fourth figure, we should have how many balls? Yes, 7 balls. And that too in shape of alphabet L, as you can see here. So now students, I am sure you have understood how the pattern is created by using shapes also. Let's move to our next topic, which is pattern of square numbers. First, let's understand what is a square number. A square number can be obtained by multiplying the number by itself. For example, 1 into 1 equals to 1, 2 into 2 equals to 4. Similarly, 3 into 3 equals to 9, 4 into 4 equals to 16. So here we are multiplying the number by itself. So these numbers 1, 4, 9, 16, they are square numbers. So a square number can be obtained by multiplying the number by itself. Students, let's understand pattern of square numbers. By using bindis, we are going to do an activity to understand square numbers using bindis. To get a square number, we have to arrange the bindis in square shape. So first paste 1 bindi. So it resembles 1 into 1 equals to 1 bindi. Then paste 4 bindis to form a square again. So this resembles 2 into 2 equals to 4 bindis. It means 2 sets of 2 bindis. Right? Now next, let's paste 9 bindis to again form a square. So this resembles 3 into 3 equals to 9 bindis, which means 3 sets of 3 bindis. And lastly, let's paste 16 bindis to form a square as shown here. So this resembles 4 into 4 equals to 16 bindis. It means 4 sets of 4 bindis. So in this way, we have created a pattern of square numbers 1, 4, 9, 16. Using this pattern, students, now can you tell me the next two square numbers? Do write them in the comment section. Now our next topic is sum of consecutive odd numbers to get square number. Now there is another way to create pattern of square numbers. This pattern involves sum of consecutive odd numbers. And what are odd numbers? Numbers like 1, 3, 5, 7, etc. So let's see how we can get square numbers using sum of consecutive odd numbers. Again, let's take some bindis. This time, take some red as well as green bindis. So here let's first put one red bindi, which means 1. Next, let's put one red bindi and 3 green bindis. Here students, one red bindi resembles the first odd number 1 and 3 green bindis resemble the second odd number 3. So 1 plus 3 equals to . Next, we have to again make a square. So let's put one red bindi, 3 green bindis and then 5 red bindis as shown here to form a square. So here students, this one red bindi resembles the first odd number 1. These 3 green bindis resemble second odd number 3 and then 5 red bindis resemble the next odd number 5. So 1 plus 3 plus 5 equals to 9. So by adding these 3 consecutive odd numbers 1, 3 and 5, we got the square number 9. And we know this 9 also equals to 3 into 3. Now to form the next square, let's put one red bindi, 3 green bindis, 5 red bindis and then 7 green bindis. So here we will do 1 plus 3 plus 5 plus 7, which is equals to 16. So by adding first 4 consecutive odd numbers, we got the square number 16. And this 16 also equals to 4 into 4. Now students, look here. These are the first 2 consecutive odd numbers, 1 and 3. So here we have 2 into 2. Next, here we have 3 consecutive odd numbers. So we have 3 into 3. Next, here we have 4 consecutive odd numbers. So we have 4 into 4. So this means we can get the sum of consecutive odd numbers without actually adding them. Let's understand this property in detail. Like if we have to add 3 consecutive odd numbers 1, 3 and 5. One way to add them is to simply do 1 plus 3 plus 5, which is equals to 9. Now another way to get their sum is by using the pattern of square numbers. So in this, how many consecutive odd numbers are there? Yes, 3 consecutive odd numbers. So we can write 1 plus 3 plus 5 equals to 3 into 3, which is equals to 9. Let's see more examples. Question is, write the sum of the following without adding. So here, let's use the pattern of square numbers to find the sum of the following. First question is 1 plus 3 plus 5 plus 7 plus 9. So these are the first 5 consecutive odd numbers. So we can write them as 5 into 5, which is equals to 25. So we got the sum of these consecutive odd numbers without even adding them. We got their sum as 25 without adding them. Next, this is the question 1 plus 3 plus 5 plus 7 plus 9 plus 11. So students, these are the first 6 consecutive odd numbers. That means their sum equals to 6 into 6, which is equals to 36. So again, we have got the sum of these consecutive odd numbers without adding them. Now look at this last question. These are the first 7 consecutive odd numbers. So this means their sum equals to 7 into 7, which is equals to 49. So again, we have got the sum without adding these consecutive odd numbers. So now I am sure you have understood this property of sum of consecutive odd numbers. Now let's move to our next topic, how to find difference of square numbers. Let's see one example. We have to solve 3 into 3 minus 2 into 2. Students, one way to solve this is by doing 3 into 3, which is equals to 9, and 2 into 2, which is equals to 4, and then 9 minus 4, which is equals to 5. Now, let's see another example. Here we have to multiply 129 by 129, then minus 128 into 128. Now again students, if we solve this by the same method we solve the above example. So first we will multiply these two numbers and then we will multiply these two numbers and then subtract them. But it is a very long process. So let's see how we can solve it by a shortcut method. Question is 3 into 3 minus 2 into 2. So to solve this, first write the first number, which is 3. And then write the second number, which is 2. Now just add them. 3 plus 2 equals to 5. This is our answer. Yes, 5 is our answer. See students, how easy it is to solve such questions using this shortcut method. Now let's do another example. 11 into 11 minus 10 into 10. Here first number is 11, second number is 10. Just add them. 11 plus 10 equals to 21. So we get the answer as 21. Now let's do a difficult question. Here question is 101 into 101 minus 100 into 100. So here first number is 101 and second number is 100. So add them and we get the answer as 201. Right, students? So now I'm sure you have understood how to use this shortcut method to find the difference of square numbers. Now let's do some questions. Question is, find the next square number after 121. So here students, we have to find the next square number after 121. And we know 121 is the square of 11. That is 121 equals to 11 into 11. So next square number will be 12 into 12, which is equals to 144. Now next we have to find the next square number after 256. Now we know 256 is the square of 16. That is 256 equals to 16 into 16. So next square number will be 17 into 17, which is equals to 289. So this is our answer. Next square number is 289. Question 2 is, express the following square numbers as the sum of consecutive odd numbers. First is 81. We know 81 is the square of 9. That is 81 equals to 9 into 9. So 81 is the sum of first 9 consecutive odd numbers. So let's write. So this is our answer. We have expressed 81 as the sum of consecutive odd numbers, where in this case it is first 9 consecutive odd numbers. Next is 144. Now we know 144 is the square of 12. That is 144 equals to 12 into 12. So 144 is the sum of first 12 consecutive odd numbers. So let's write 144 as sum of first 12 consecutive odd numbers. Next question. If 4 is the first square number, which is the fifth one? So here it is given, if 4 is the first square number, which will be the fifth square number? So let's write, first square number is 4. It means 2 into 2 equals to 4. Second square number will be 3 into 3 equals to 9. Next will be 4 into 4 equals to 16. Fourth square number will be 5 into 5 equals to 25. And now fifth square number will be 6 into 6 equals to 36. So this is our answer. If first square number is 4, then fifth square number is 36. Now let's understand triangular number pattern. The triangular number pattern is the representation of the numbers in the form of an equilateral triangle. Students, let's do an activity to understand triangular number pattern using bindis. So first, paste one bindi. It represents 1. Then paste 3 bindis to form an equilateral triangle. Right? So we have pasted 3 bindis here. Next, let's make another equilateral triangle. For this, we will paste 6 bindis as shown here. Next, let's form another equilateral triangle by pasting 10 bindis. So students, first number in triangular number pattern is 1, second number is 3, third number is 6 and fourth number is 10. Now can you continue with this triangular number pattern and tell me the fifth number in this pattern? Write in the comments box. Students, let's understand more about triangular numbers. First triangular number is 1. Second triangular number is 3, which can be written as 1 bindi plus 2 bindis. Now third triangular number is 6, which can be written as 1 bindi plus 2 bindis plus 3 bindis. And fourth triangular number is 10, which can be written as 1 bindi plus 2 bindis plus 3 bindis plus 4 bindis. So here we observe that first triangular number is 1, second triangular number is sum of first two numbers, third triangular number is sum of first three numbers, and fourth triangular number is sum of first four numbers. So to find fifth triangular number, we will add first 5 numbers. Right students? But now, if I ask you to find 11th triangular number, then adding first 11 numbers will take lot of time. So let me tell you a shortcut method to find any triangular number. First, let's find fifth triangular number. To find fifth triangular number, first we will write 5. We are finding fifth triangular number, so first we will write 5 and then we will multiply it by next number, which is 6, and divide both of them by 2. Now simplify this. We get 5 into 3, which is equals to 15. So this is our answer. Fifth triangular number is 15. Students, you can add the first 5 numbers and you will get the sum as 15 only. So this shortcut method is very easy and useful to find any triangular number. Let's do one more question. Find the 11th triangular number. Since we have to find 11th triangular number, so we will multiply 11 by next number, which is 12, and then divide them by 2. Simplify it. We get 11 into 6, which is equals to 66. So 11th triangular number is 66. Now let's do a different question. Question is, find the next triangular number 10, 15 and then the next. So we are given two triangular numbers here, 10 and 15, and we have to find the next triangular number. So let's see how to solve such a question. First students, find the difference between the two given triangular numbers. So 15 minus 10 equals to 5. Next, add 1 to this difference 5. 1 plus 5 equals to 6. So we have got 6 now. In the next step, we will add this 6 to 15 to this triangular number to get the next triangular number. So 15 plus 6 equals to 21. So this is our answer. Next triangular number is 21. Let's do one more such a question. Find the next triangular number. So here we are given these two triangular numbers 325 and 351, and we have to find the next triangular number. So let's solve this question in the same way as we solved the previous question. First, we will find the difference between these two triangular numbers. So 351 minus 325 equals to 26. Now add 1 to this difference 26. We get 26 plus 1 equals to 27. Next, add this 27 to 351 to get the next triangular number. So we will do 351 plus 27, which is equals to 378. So this is our answer. 378 is the next triangular number. Next question is, if 3 is the first triangular number, which is the fifth one? So here we are given that 3 is the first triangular number and we have to find the fifth triangular number. Students, according to this question, 3 is the first triangular number and we know 1 plus 2 equals to 3. So it means sum of first two numbers is first triangular number 3. So second triangular number will be the sum of first three numbers, which is 6. Similarly, third triangular number will be sum of first four numbers, which is 10. Then fourth triangular number will be sum of first 5 numbers, which is 15. And fifth triangular number will be sum of first 6 numbers, which is 21. So this is our answer. 3 is the first triangular number, then fifth triangular number is 21. Now the last question is, name two numbers which are square as well as triangular numbers. So here students, we have to write two numbers which are square numbers as well as triangular numbers. So first, let's write some triangular numbers. 1, 3, 6, 10, 15 and so on. These are triangular numbers. Now look at these numbers and see if any of them is a square number as well. Here we know 1 is a square as well as a triangular number. So we have got the first number which is a square as well as a triangular number. Now we have to find the second number. Now 3, 6, 10. These numbers are not square numbers, right? Then 15 is also not a square number. 21, 28 are also not square numbers. Then students, we have 36. Yes, 36 is a square number because we know 6 into 6 equals to 36. So 36 is a square number. Now let's also see why 36 is a triangular number. Because 36 is a sum of first 8 numbers. So 36 is the 8th triangular number. So students, we have got the second number as well. So we will write 1 and 36 are square numbers as well as triangular numbers. Now in the end, I am giving you a worksheet for your practice. This worksheet contains questions from all the sections of the chapter which I have just taught you. So before attempting this worksheet, I will suggest you to watch this video carefully. You can match your answers from the answers available below in the description box. Do watch my other videos and share my channel and my videos with your friends and family. Thanks for watching. See you in the next video. Bye-bye.